recording as well. So please write about the magnitude of focal length of different lenses. Say in 10th grade you might have learned this particular thing that f is equals to r by 2 even for lenses, right? But this is wrong. This is not true. We'll try to do this thing. Na? See, by lens maker's formula, we have 1 by f will be equals to what? 1 by f will be equals to mu2 minus mu1 upon mu1 into 1 by r1 minus 1 by r2, right? You have this formula, right? This is what we derived in the last class. Everyone, you remember this? Acha, can I write this formula as one more thing? Can I write it like mu2 upon mu1 minus 1 into 1 by r1 minus 1 by r2, right? Where what was this mu2? Guys, do you remember mu2 was basically the medium of lens? Mu2 was basically the medium of the lens, and mu1 was basically the medium of surrounding. Do you remember this? Yes or no? So in spite of writing mu2 and mu1, I'll write it as mu L. So lens maker formula, I can write it as mu L upon mu S minus 1 into 1 by R1 minus 1 by R2. And what is this? Refractive index of lens with respect to surrounding. Is this refractive index of lens with respect to surrounding?
Yeah.
So please remember this, this is the most common formula we'll be using. We'll be using this very much often. This is our lens maker's formula where mu ls is basically refractive index of lens with respect to surrounding. So anyways, we wanted to define what is this focal length in various cases, right? So if I want to define the focal length for a biconvex lens, so the A part is for a biconvex or a biconcave lens. Since we are talking only about the magnitude part, so I don't care whether it is biconvex or biconcave lens. है ना? Tell me this particular thing, if it is biconvex or biconcave lens, then if suppose this radius is r1, this radius is r2, this radius is r1, this radius is r2. Can you see over here? R1 will, if r1 will be negative or positive in this case? In this case, r1 will be, if I choose this convention, ki positive is towards this and negative is towards this. So here R1 will be positive and R2 will be negative. And here R1 will be negative and R2 will be positive, right? Yes or no, guys?
Yeah.
And so this is how you define for this is your R1 and this is your R2. Similarly, this is your R1 and this is your R2. Is this clear? From here, can you see over here? In the case of a biconvex or a biconcave lens, R1 and R2 will always have opposite signs. Will they always have opposite signs? Yes or no?
Yes,
Yeah.
sir.
So if they will have opposite signs, that implies, if I just calculate the magnitude, so basically this will be positive and this will be negative. So negative will become positive. So there will be a plus sign over here. Although to a complete negative sign can be taken out, right? But since I'm talking only about the magnitude, I can write this will be 1 by r1 plus r2 and 1 by r1 minus r2. 1 by r1 minus 1 by r2 will become 1 by r1 plus r2 plus 1 by r2. Or ultimately, when you'll solve for focal length comes to be r1 r2 upon R1 plus R2 into mu of length with respect to surrounding magnitude. So this is basically the magnitude of a biconcave lens or a biconvex lens. This is the formula. So can you see it is nowhere dependent on f by 2, it is not r by 2. Are you getting my point, guys? Special case, if I say for equiconcave or equiconvex lens, for equiconvex or equiconvex lens, you know what will happen? R1 and R2 will become equal. If R1 and R2 are equal to R, then the magnitude of F will be, can you see, R into R square upon 2R. So this will become R upon twice of mu minus 1 into 2. This is the magnitude for a equiconvex or equiconcave lens. Is it clear? Is it clear, guys? The second case is basically for a प्लेनो कॉन्वेक्स लेंस या फिर प्लेनो कॉनकेव लेंस. If I have a plano convex and plano concave, so suppose if I have this or this, या फिर if I have this या फिर this. Tell me this particular thing is, are all of them plano convex or a plano concave lens, right? These are plano concave, these are plano convex, right? Hello. So here R1 is
Yes,
there,
sir.
R2 is there, R1 is there, R2 is there, R1 is there, R2 is there, R1 is there, R2 is there. Can you give me the values? R1, let's say R1 here, it's a curved surface and the radius of R1 is R. R2 is the plane surface, so hence the radius is infinity. Similarly, R1 here it is plane, so hence its radius is infinity, and R2 is, let's say, R. Okay. Same goes over here. Here R1 will be something, but R2 is infinity, and here R1 is infinity, but R2 is something, right? If I use conventions over here, positive in this side, negative this side. Achha, can you see over here, guys? In the case of a plano convex or a plano concave lens, one radius, one radius is something, and another is basically infinity, right? So if I put these values in basically the lens maker's formula over here, then one of these will become what? Zero, because 1 upon infinity is 0. And can you see only 1 by r will remain if I just want the magnitude, and then I'll take the reciprocal, so it will become what? The final answer for this, magnitude of f will become r divided by, this is the focal length for a plano convex lens or a plano concave lens. Magnitude I'm talking about, only magnitude. Is it clear? Is it clear, guys?
Yes, sir.
ठीक है, लिख लो. The last one is a concavo convex or a convexo concave lens. So if it's either this lens or this lens, either if it is this or this is the concave or convex, and you see the surfaces are intersecting. Here the surfaces are non-intersecting, right? So here R1, if I say this is R1 and this is R2, this is R1 and this is R2, can you see if I place it like on the left or on the right, does not matter. But can you see over here, R1 will be also on one side and R2 will also be on the same side. So can I say here also the same thing, R1 and R2 will be on the same side. So can I say R1 and R2 will be in the same direction. If they will be in the same direction, then what will happen? Both will have the same sign. If both will have the same sign, then it will be either R1 minus R2 or R2 minus R1. But since we're talking only about the magnitude, the final answer, if you'll write, so F is basically, the magnitude of F is basically equals to R1 into R2 divided by magnitude of R1 minus R2 into mu L S minus 1. So this is the magnitude of focal length of a concave or convex lens. Is this clear? Is it clear, guys?
Yes, sir.
Please remember this thing. Note करके लिख लो. Note. Focal length depends on two factors. Always remember. Focal length depends on two factors. First factor is basically the factor which is relating the radius. Can you see this one? Right? Yes or no? This
Yes, sir.
factor. Now, can you see this factor? It's positive for all type of convex lenses. And if you want the analysis, you can try to take any particular lens. Acha, by the way, I'm talking about this convention, huh? Positive, negative. So this factor will be positive for all type of convex lenses, and this factor will be negative for all type of concave lenses. I can try with the help of two. Can you see over here? Uh, huh. This is basically the formula. Shall I explain how? Okay, it's fine, guys. See, if I example के रूप में कभी if I give you a biconvex lens. If I have a biconvex lens, then can you see R1 is positive and R2 is negative, right? Yes or no? R1 is positive, R2 is negative. And what is the lens maker formula? 1 by F is equals to mu minus 1 into 1 by R1 minus 1 by R2. So can you see, you can, R1 is positive, so you will put positive over here, and R2 is negative, so you will put negative over here. So overall this factor will be positive, right? Yes or no? Similarly, if I have, let's say, this, है ना? So here R1 will be, tell me, R1 will be infinity and R2 will be negative. So can you see, this factor will be in 0 and this factor will be minus of 1 by R2. R2 is negative, 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 again positive. If you don't place it like this, you place it like this. So can you see, R1 is over here, R2 is over here. Now R1 is positive, but R2 is, are you getting my point, guys?
Yes, sir.
Infinity. I won't explain for concave lenses. You need to do that on your own analysis, है ना? So here also R1 is positive, so this whole thing is positive, this whole thing is 0. Again this factor is positive. If I have a concave or convex lens, then can you see, R1 is over here, R2 is over here, but can you see which radius is greater? Can you tell me? The curvature, whichever has a higher curvature will have a lesser radius, right? So R2 has more curvature, than R1. That implies, always remember, R1 is basically then greater than R2. Okay, जिसका भी curvature ज़्यादा है, the one which is more curved will have a lesser radius, and the one which is less curved will have the more radius. So उल्टा होता है. So R1 is greater than R2 in magnitude, and can you see both are negative? If I say R1 R2 both are negative over here, R1 and R2 both negative. So if I put this over here, so this will be also negative, this will be also negative, right? But this negative negative will become positive, and ultimately it will be 1 by R2 minus 1 by R1. And now can you see over here, R1 is greater, so you'll put this greater thing over here, and R2 is lesser. So you'll put this lesser thing over here. So this will become ultimately R1 minus R2 upon R1 R2, right? So can you see this whole thing will be a positive thing again? Are you getting my point, guys? Any doubt in this part? The same type. You want to write this thing or it's fine? Shall I erase this? No need to write this thing, na? This is just
Hmm.
analysis. Always remember, if I choose that convention, then the focal length for all will be positive for all type of convex lenses, and the focal length will be negative for, this factor will be positive for all type of convex lens, and this factor will be all type of negative for concave lens. Now, second thing is the factor, this factor. Do you remember this? Or basically mu L upon mu S minus 1, this factor. Okay. So now, first is this, if the lens, the refractive index of the lens is greater than the refractive index of the surrounding. Matlab basically, lens is denser than surrounding. If the lens is denser than surrounding, then what will happen? Guys, if the lens is denser than surrounding, then what will happen? This factor will be greater than 1. If this factor will be greater than 1, then positive. Are you getting my point, guys?
Yeah.
So the factor, this factor is basically positive when this happens, and it will be negative when medium of lens is less dense as compared to the lens is rarer than surrounding. Then this thing will become negative. Now, ultimately, the focal length will be basically decided by what? Factor 1 multiplied by factor 2. So now you can easily predict the sign, right? If this sign is both are positive positive, then f will be also positive. If one is positive, one is negative, then negative. One is negative, one is positive, then positive. Both are negative, then again positive. Is it clear? Is it clear, guys? Array, is it clear, guys?
Yes, sir.
ठीक है. चलो. So these were the factors on which the focal length differs, and accordingly we can, so depending, we can write depending on signs of factor 1 and factor 2, we decide the direction, or basically we design the sign for focal length. Is it clear? So basically I talked about what in this section. What did I talk about? I talked about the magnitude, and can you see the direction, or basically the sign of focal length? I told you it depends on two factors. So I talked about the magnitude as well as the direction. Is it clear? एक बार please go through it once again and check whether if you have any doubt or not. We'll start with the questions then. Guys, by the way, the lens ke all the 6 diagrams, I am not interested in drawing those, and I am giving you as a homework to do all the 8 diagrams for lenses. We'll directly start with the lens formula derivation today. Guys, are you done? Please write the question. To symmetric double convex lens. Acha, what do you mean by double convex lens? And symmetric, or I have added symmetric, that implies it's what kind of lens? Hello. So this is the question. There are two symmetric double convex lens. The by symmetric double convex may I means what? Biconvex. This is biconvex. Sorry, equiconvex. Okay. So this is symmetric double means equiconvex. Now they have given what? The focal length is basically, oh sorry, not the focal length, the radii of curvature is r of a is basically 0.9 times of r of b. Acha, by the way, the focal length of a equiconvex lens is given by, remember f is basically r upon twice of mu minus 1. You remember this? Mu is what? Mu is the medium length with respect to surrounding, right? Yes or no?
Yeah, yeah.
So basically they have said ki they have the same focal length. If they have the same focal length, then RA divided by twice of mu A minus 1 should be equals to RB divided by twice of mu B minus 1, right? And from here I can rearrange them. RA upon RB is basically mu A minus 1 upon mu B minus 1. 2 and 2 will get cancelled out, and they have given RA upon RB to be 0.9. So I think, and mu A is also given, है ना? Mu A is 1.63. It's given in the question, right? So I think you people can solve for mu B. The answer will be 1.7. So try to solve and you'll get your answer. Next question. Guys, the meeting will end in 10 minutes. So after this, please join again. Try to do this. So now see what is given to you guys. They have already said that the radius of one surface is basically twice of other. So I'm taking R2 as basically twice of R1. Achha, by the way, if R2 is twice of R1, then which will be the more curved one? Guys,
R2.
R2 will be more curved, right?
Yes, sir.
Because it has less radius. Since R2 has more radius. Hey, ulta. Sorry, we did ulta, right? If I say R1 is basically twice of R2. So R2 is smaller? Yes or no? Yes or no? So less radius, more curvature. Is it clear?
Yes, sir.
So anyways, now we know the focal length of a biconvex lens is given by R1, R2 divided by, achha, it's a biconvex lens, the radius will be of opposite sign, hence it will be R1 plus R2. If you remember, we just wrote this thing. You just put the value of R1, R2. F is given to you. F is given to you how much? So F is given to you 50 centimeter. So R into R2 is basically, if R1 is equals to, if R2 is equals to R, then R1 will be equals to 2R. So it will be 2R multiplied by R divided by, refractive index is 2 minus 1 divided by twice of R plus R, right? And I'm not putting any signs in this, guys. Why? Because I'm just want to calculate the magnitude. So 50 will be equals to 3R square divided by, oh sorry, 2R square divided by 3R. 1R will cancel with 1R, and R will be equals to what? 3 by 2 times of 50, which will be 75 centimeter, right? So R की value आ गई कितनी? 75 centimeter, and we have assumed this thing that R2 is equals to R and 75 centimeter, and R1 will be basically twice of R, which will be 150 centimeter. Now I want you to find out the radius of curvature of the surface having more curvature. So curvature किसका है? What is the answer to our question? Is this the answer or is this the answer? This will be the answer. It has less radius, more curvature. Is it clear, guys? Chal. So
Yes, sir.
the homework for you for today will be the 8 diagrams for lenses. है ना? So you need to draw 8 diagrams, 6 for biconcave lens, 6 for biconcave, oh sorry, biconvex, and 2 for biconcave. ये खुद कर लेना. I am not doing anything. I will not do the diagrams in this case because वही फिर time बहुत सारा waste होगा. So it's better if you do it on your own. Is it clear? Guys, is it clear?
Yes, sir.
चल, heading डालो, lens formula, and let's try to prove it. Although there is no proof for lens formula in your textbook, I guess, but we can prove it, yaar, if possible. Let me check. Hmm. So suppose, guys, I think this is not with uh, O, B, and alpha. It's not with that. So I think whenever the derivation for lens formula will come, then you need to use the trigonometry one. Now, let us say there is an object over here, and let us say light gets reflected, and its image forms over here. Okay, I'm drawing a rough diagram, so don't it doesn't matter. This is our object A, B. This is O. Let's say this is P. Uh, then this point is basically F. Yes or no? Guys, is the
Yes.
diagram clear? I've just drawn a rough diagram. I'm not drawing a very detailed diagram or anything like that. I'm just drawing a rough diagram. This is basically this is A dash and this is B dash. The image of point B is basically forming over here. Array, it's better to take this. This is our A. This is our B. This is F. This is B dash. And this is A dash. Let's say. Take it. Shall we start then? So now, can you see, guys? There are two triangles. There are two triangles found over here. There is this triangle OPF. This one. Can you see OPF? Yes or no? Is this triangle similar to triangle FB dash A dash?
Mm. Yeah.
Yes or no? Is this triangle similar to this triangle? Yes or no?